For power, W over
Let's do these together, but by taking turns. So you should all have the first one finished by now. The first two. So the first one, what's the power?
100 watts.
100. And what else do you know? The voltage is 220. And what do I want? The current.
Yeah.
So P equals IV, I equals P over V, which is 100 over 220.
0.46.
What is it?
0.46
Right, that's fine. Number two, I give you the current
volts.
and the volts.
Current is 2 ampere.
Is it 2? No, it's 10. What is the power? The power equals IV, which is 2000 volts, which is 2 kilovolts. Oh, watts, sorry, thank you. Now, number 3, the interesting one. Anybody get number 3?
No, that's still lower.
That's a car.
Uh-huh.
It's a
It's
it's an SUV. Yeah.
This is Mercedes.
Yeah, it's a Mercedes. Yeah, it's an SUV. Right. So we know the speed. What is it? 20 meters per second. What else do we know? We know the force in the engine is 2,000. Yeah. No, 5,000. 5,000 newtons. What else do we know? Oh, and in the battery here, it's 276 volts in the battery. Yeah, and what do I want? The resistance. Right, now watch carefully, please. Nobody got this? So we can use our triangle VI-OR. So OR equals V over I, which is 276 over I, and we don't know the I, so now we need to think about what the I is. So we can use that power equals IV. So then the I equals the P over V. But power is work over time over volts. So it's work over volts multiplied by time. Now what's the formula for work? Force multiplied by distance over volts multiplied by time. But what is distance divided by time? Speed. Now this V is speed and this V is volts.
Okay.
Do we know the force?
Yes.
Yes. Do we know the speed? Yes. Do we know the volts? Yes. So now we have the current. 5,000 times 20 over 276. This comes out at 362 amps. And that goes back in here. Giving me 0.76 amps. And then that's it, that was the OR. Oh sorry, I wrote amps, I meant ohms.
Okay.
It's a great question because it puts everything from mechanics and electricity together. Really have to think about this one.
I was stuck at the time. In FS over V.
Here to here?
Yes.
Yeah,
Because I didn't know what the time is. Like I didn't know.
exactly.
But it's S over T. That's already there.
Yep,
You
Yeah.
just change the speed.
yep. Okay, can we look at number 4 now? So, number 4 is a 2 ohm laptop and it's 2 seconds to charge up and the charge is 100 millicoulombs. What's the energy? So, we have two formulas for energy. We can use a half QV or we can use a half CV squared. Now, which one should we use here? Well, do we know the C? Yeah. Do we know the V? No. No, we have the T. Now what is this T? That's actually like the 5 tau.
Yeah.
So we have 5 tau equals 2. But what's tau? That's 5 or C equals 2. So now what we can do is we can say or equals 2 over 5c. What did I say the c was? 0.1. So what's this now? This is 4 ohms. Now is that any good? Well, no. We probably want to use this formula, but we don't know what the V is. Does our triangle help us?
Do we have the I?
Do we have the I? Good question. Do we have the I? No.
We only have that.
We have the or though, and we have the C, and we have the time. Yeah. We could also maybe use something like power equals what was the work over time. Do we know the power? No. Do we know the time? Oh, okay. Do we have enough for this actually?
We have to find what?
We have to find the work. We need the V. The V is I or. We have the or. Do we have the I? No. I don't think I gave you enough information for this question. I think something. Wait a second. Wait, hang on. It says a 2 ohm laptop.
We have the R, but that doesn't change it.
But that or is different to this one.
Yeah, that's the only thing.
2 seconds. 2 seconds.
Let's say QR. Let's say Q.
The what? The charge is Q.
It's not C.
We don't have C. We don't have C.
Oh yeah, yeah. Oh, that should be.
It's
Oh, that's
Q.
Q. That's Q, not C.
Yeah, not C.
Sorry, being stupid. Thank you. So Q equals 0.1 coulombs,
Yeah.
and I don't know the V. Yes, okay. Right, so I have work is that and a half CV squared. So I feel like I should use this one. Yeah. So work equals a half QV. Now I know the Q and the half, so I just need to get the V.
We know the R.
And we know the or, and we have VI or. And I tell you the or is
2 ohms.
2 ohms.
Yeah. Now what?
Yeah.
Yeah, now what? I also tell you the time is 2. So we have,
You should give us one more.
now I'm trying to do with this information. We know that the tau, the 5 tau equals 2, the 5 or C equals 2. I know the or, what's the or? I said in the question, it's 2. So the C is 0.2.
Yeah.
So Q is also TV.
But you don't have the V.
So now we have Q and
Yeah, but I know,
C.
We still need the I.
yeah,
No. Q is equals to CV.
yeah, Q equals
So V
CV.
is equals to Q over C.
Okay.
So V equals Q over C, and I have the Q
And the C.
and the C, japers. Right, so V equals, what did I say the Q was?
Q is
0.1. And the C?
0.1.
0.2. So the V, 0.5.
Yeah.
Thank goodness. And now I can put that in. A half Q, 0.1. V, 0.5. Wow, this was a hard one. .025 joules. Wow, that was hard. Yeah, I made these ones hard. Okay. But anyways, with patience and thinking about all the formulas you have, you can get to it. Right, next one. Yeah. What the heck was this letter? C.
Yeah.
What the heck is this then? C. C is capacitance, so the unit is farads here. And this was volts. Continue, please.
Yes.
Yep. Right, the last two more. A 2,000 millifarad is fully charged and does 2 joules of work. What is the voltage? Okay. So we know, what do we know here? The capacitance is 2 farads. And then the work is 2 joules. And what do I want? The voltage. So what formula could I use here? W equals a half Q V, or W equals a half C V squared. Yeah, I can just use this one, can't I?
Yeah.
So what's the W? 2. And the C? 2. This is easy.
Yeah.
I made this one too easy. V is square root 2, 1.41 volts. Yeah. Okay, one more and then we'll start the next lesson. Yep. Lastly, a flash camera does 5 joules of work in a time of 100 milliseconds. That's 5 tau.
Yeah.
This is provided by a capacitor under 4 1.5 cells. So what is the total voltage if there's 4 of them? Yeah, multiplied. So the voltage equals 6 volts. And what do I want? The resistance. Right. So VI/R. The resistance is V over I. Do I know I? No. But I have another formula for I. I is also QT. Do I know the V? Yes. Do I know the T? Yes. Do I know the Q? No. But I have another formula for Q. I can say, what is it? Q equals CV. So this will be V over CV T. Which will be 1 over CT. Do I have the C?
No.
No.
I have calculated in.
But you can get it from here.
No.
But we don't have ours.
Always have 2 equals.
Oh my god.
No, it's okay because we can remember, we can say 5 time constants equal or C.
Yeah.
So this is 1 over C times 5 time constants, that's the time. And we know what this is. But
0.1.
Now is 0.
hold on.
0.1.
It's 0.1.
The time is 0.1.
Yeah, 0.1.
So 1 over C.
Do we have the or? No, I think I have to go backwards. Right. I think for this it might be easier just to work out what we can work out. So for example, we have the formula W equals a half QV. And we know the W and we know the V, so we can get the Q. Maybe this will be helpful. So Q equals, it would be 2W over V.
V squared.
In this?
No.
No, this is right, I think. What's the W? 5. And what's the V? 6. So we get Q equals 1.67 coulombs.
Okay.
Right. We also know that the time constant is 0.1 over 5. which will be 0.02 seconds. And we also know the time constant equals RC. But I don't know the C, so I should use a different formula. We also have Q equals IT. And we know the Q and we know the T, so we can get the I. And then we can get the resistance. But the problem here is because it's a capacitor, it's changing, so maybe I don't want to use that. If I got the C unfinished, work equals a half CV squared. Yes, I know the work, what is it? 5. I know the voltage, what is it? 6. So can I get the C here? Yeah, so C equals 5 times 2 divided by 36. 0.2778 farads. Right, now, what can I use to get the OR? I can use 5 time constants equal RC. So the OR equals 5 time constants over, time constant equals RC, so time constant over C, which is 0.02 over 0.2778. Whew, finally, 0.072 ohms. Yeah, hard. They don't make them, I don't think they make them this hard in the exam.
I hope so.
Indeed. Continue?
Yes. We start next chapter?
Yeah.